Hello viewers, welcome back to class. I'm super excited to have you guys back to class again. Please, as a reminder, don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. Don't forget to share this video, don't forget to like this video, and don't also forget to make your necessary comments at the comment section below. Guys, don't forget, let me sound this as a reminder. Do not forget our policy here that no part of this video should be skipped. This is for your own advantage. So ensure that as you watch this video, you do not skip any part of this video so that you may not skip the part that will actually give you what you need to know or to gain mastery over this aspect of this topic. And also ensure to avoid every unnecessary distractions anytime you are set to watch and to learn new concepts from our platform. And finally, if there be any part in this video you do not understand when you watch it for the very first time, please guys, you have the opportunity to replay the video over and over and over and over and over and over again until it sinks into your mental capacity. Please guys, let's get to work. Now on the board we have second order differential equation, and now we have been providing solutions to second order differential equation. I will say that in providing solutions to second order differential equations, there are two major cases. Case one is when f of x is equal to 0, which is the right hand side of the second order differential equation is 0. That is case 1. We have looked at that. Then we are looking at case 2, where f of x is not equal to 0, but any value of x. Just as we have here, case 2, when f of x is not equal to 0, but f of x is any value of x. Are you there? Or any function of x. We said we have constants, which we have looked at already. We have linear, which we have equally looked at. Then we have quadratic, we have looked at that. Now we want to be looking at exponential functions. And for exponential functions, we have that the f of x is given as equal to exponential kx, where k is the coefficient of x, which can either be a positive or a negative integer. Are you there? Then, for such problems, the particular integral is equivalent to what y, and y is equivalent to what c, exponential kx. Now understand that c there is the arbitrary constant. Are you there? And for every particular integral that you solve for in second order differential equation, you always obtain the values for the arbitrary constant. If this is understood, then we can get to solving problems under this case. Guys, we have question number 7 on the board. Of course, it's the first question under this category, but it happens to be question number 7, being that this class is a continuation class. Are we done? Now let's look at it. We are asked to solve 2d squared y over dx squared minus 7dy over dx minus 4y is equal to exponential 3x. Exponential 3x. Now, as usual, the first thing that you look at for is to watch closely if you have an existing equation or function at the right hand side of the second order differential equation that you are given. Now, when we look at the right hand side of this equation, we find out that we have exponential 3x. And of course, exponential 3x is a function that exists. It's not 0. That is to say, this particular second order differential equation that we are given contains two parts. One part of it is the complementary function, the other is the particular integral. Hence, the general solution to this question would have become the sum of the complementary function and particular integral. And like I have advised over time, made you to understand that it is always easier for you to define the feature from the beginning. And how do you define the feature from the beginning? Now we have ascertained that this question we are given contains two parts, which include the complementary function and the particular integral. So all we need to do here is to state that the general solution is equal to complementary function plus particular integral. Then we will call this as equation 1. Then the next thing we quickly do is to repeat this given equation, d square y all over the x squared minus 7 dy over dx minus 4y is equal to exponent 3x. Then let's label this as equation 2. Now, guys, what is the next thing? The next thing is, now that we know that our general solution is the summation of complementary function and particular integral, then the question is, how do I obtain the complementary function? And equally, how do I obtain the particular integral? First, let's start with the complementary function. You know that for you to be able to obtain the complementary function for any second order differential equation, you must ensure that the right hand side of the equation is equated to 0. That means I need to remove or replace exponential 3x from the right hand side with 0. Therefore, all I need to do here is to state what I want to find first. So to find the complementary function, let the right hand side of our equation to be equal to 0. So if I understand the depth, all I need to do is to put down d square y over the x squared minus 7 dy over dx minus 4y is equal to 0. Then we can label this as equation 3. Now that we have obtained equation 3, guys, the next thing we are quickly going to do is to obtain the equivalent auxiliary equation of this particular equation. Of course, you know that there is no way you can obtain the auxiliary equation if the right hand side of the second order differential equation you have given is not equal to 0. Now that we have successfully equated this to be 0, then we stand the chance to convert this equation to its equivalent auxiliary equation. And we know that this square y over dx squared is represented by m squared, the y over dx is represented by m, y is represented by 1. So all we need to do is to multiply 2 by m squared. Then we multiply 7 by n, and we multiply 4 by 1, which will equally give us 4. This is equal to 0. Then we tag this as equation 4. Now, guys, you understand that this equation 4 is what we call the auxiliary equation. And for every auxiliary equation you have for second order differential equation, you definitely have a quadratic equation. And we understand that for every quadratic equation, we have 2 roots. Now, what are the methods of solving quadratic equation? This will be the next question that will pop up in your mind. Of course, we have about 4 methods of providing solution to quadratic equations. So in this class, we have been using factorization method, except for equations that are not factorizable. Of course, now, equally, I have taught you how to test run if a particular equation is factorizable or not. Now, without wasting much of our time, from experience, I already know that this equation is factorizable. So you can test run with the 2 methods I taught you earlier. Now, listen carefully. The first thing you do is to multiply the leading degree with the constant. And when we multiply 2m squared by negative 4, we will have negative 8m squared. And understand that the next thing we are quickly going to do is to look for 2 factors such that their product will give us minus 8m squared, but their sum would have given us minus 7m. Okay, so we know also that for the product of 2 factors to be negative, one of the factors must be negative. I've told you several times that when you know principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundary. That is why it is better you understand the basic rules. This is what will give you an edge to gain mastery over that aspect of problems that you are looking at. Now let's look at this. So in this case now, I already know that this will have given us 2m squared minus 8m plus m minus 4 is equal to 0. Of course, minus 8 plus m would have given us minus 7m, and minus 8m multiplied by 1m would have given us plus minus 8m squared. So that means we are correct. All we need to do is to group these 2 terms, first 2, and equally group the last 2 terms. Now, when I look critically to the first 2 terms, I found out that 2 is the common factor. Put down 2, and equally m is common between the 2 terms. In other words, between the first 2 terms, we have 2m. as a common factor. Alright? So when 2m squared is divided by 2m, we are left with just m. Okay? Now equally when 8m is divided by 2m, now m cancels m. We have 8 divided by 2 would have given us -4. Then plus. Now between the last two terms we have m and -4. Of course we know that there is no common factor, and I've explained countless times that anytime you are factorizing any particular expression and you find out that there is nothing that is common between any two terms, it shows that one is common, because one multiplied by any number will give you the same number. Are you there? So we say here that 1 is the common factor between m and -4, and this is equivalent to 0. Now that we have successfully had this level where we have the two brackets equal, then we are quickly going to pick the multiplication factors and equally pick one of the equal bracket. Now the multiplication factors, we said that they are the factors that are outside the bracket. Of course we have 2m, and finally we have +1. This will have given us one bracket. Then we pick one of the equal brackets. This is equal to 0. And by extension, we understand that for the product of two factors or two functions to be 0, one of the factors must be 0. Of course, we have two factors here, but we do not actually know the one that is 0. So therefore, we will assume either the first bracket is equal to 0 or the second is equal to 0. This is where probability comes in, because we are not certain about the particular function that is equal to 0 for the product of these two functions to be 0. Therefore, we have 2m plus 1 is equal to 0, or m minus 4 is equal to 0. Now, from here we are going to make m the summary of formula. We have this as 2m is equal to, when plus 1 crosses the sign of equality, it becomes -1. And when -4 crosses the sign of equality, it becomes +4. Of course, at this point now, we have the coefficient of m to be greater than 1. Therefore, we need to divide both sides by 2. Then we have m is equal to -1/2, or 4. This is the answer to this equation. Now that we have successfully obtained this result for m, the next thing you are quickly going to do is to identify the roots that you have there. Of course, we know we have real and different roots. We have real and equal roots. Then we equally have complex roots. But in this case now, these roots here, they are real and are different. Then we can simply select m1 be the first value and m2 becomes the second value. So now, anytime you have real and different root, what is the general solution to that second order differential equation? We have that y is equal to a exponent m1x plus b exponent m2x. Of course, we have that y is equivalent to a exponent m1 is minus 1/2, which we are giving us x/2. Alright? Then plus b exponent 4x. Now, guys, this is exactly the same thing as our complementary function. Now, we have successfully obtained the complementary function. The next is to obtain the particular integral, and this is where the knowledge of the function you are given at the right hand side of the equation matters, because for you to be able to get the actual or the correct answer for your particular integral, you must be able to identify the function of x that you have at the right hand side of the given equation. Now we have exponential function. So how do we obtain particular integrals anytime we have exponential function? That's when you come to this knowledge of this equation. So we have that to find particular integral, let particular integral is equal to y equivalent to c exponent kx. Now in this case, when we look at the question we're given, we have 3 in place of k. So you're not going to put k here, but we will equally put what 3 here. Alright, so this is what we use to replace our k, because the k is the coefficient of x, like I explained before. And the coefficient of x, we already have it here as 3. So we have c exponent 3x. Now guys, all we just need to do here to find a particular integral is just to obtain the value of c. And for us to be able to obtain the value of c, we must differentiate this equation 2 times. Then we will now substitute into the given equation that we termed as equation 2. Now when we have if y is equal to c exponent 3x dy over dx. When you differentiate exponential function, all you just need to do is to bring down the coefficient of what? The exponential. Or simply we differentiate 3x, which is the power of the exponent. When you differentiate 3x, you have 3. That 3 becomes the coefficient. So you now have 3 multiplied by the existing coefficient, which is c exponent 3x. Understand that the power doesn't reduce. Then we differentiate again the second time, which will have given us the second derivative. And this is equivalent. So when we differentiate again, we are still going to differentiate the power of the exponent, which is 3x. And when we differentiate 3x, we have 3. So 3 multiplied by the existing 3 here, we will have this to be 9. And this will have given us 9c exponent 3x. This is what we have. Then at this point, guys, all we need to do is to come to equation 2, or the given equation either, any way you want to take it, and substitute for this y over dx, dy over dx, and y via the 3 results that we have here. So I come to this point and I have 2 multiplied by 9c exponent 3x, right? Then minus 7 multiplied by 3xc exponent 3x. Then minus 4 multiplied by c exponent 3x, all equal to exponent 3x. This is what we have. So at this point, all I need to do is to clear up the brackets. And to have this done, 9 multiplied by 2, this will have given us 18c exponent 3x minus 21, 7 multiplied by 3, c exponent this minus 4c exponent 3x equal to exponent 3x. So guys, at this point, we see that at the left hand side, c exponent 3x is common. So we can factorize this and have c exponent 3x is equivalent to 18 minus 21 minus 4 is equal to exponent 3x. So we can divide both sides by exponent 3x. We will be left with 1 at the right hand side of this equation. And hence, at this point, all we need to do when we remove 21 from 18, we will have negative 3. And negative 3, negative 4 would have given us negative 7. Or 18 minus 21 minus 4 is exactly as minus 7. Your calculator can give you this. Then we have this as minus 7c is equal to 1. Now we are looking for the value of c. Then we will make c the subject of formula by dividing both sides by minus c. Then we have this to be what? Minus 1 over 7. This is c. Therefore, the particular integral, which is y, is equivalent to c exponent 3x. There we have particular integral is equal to, what is c? C becomes minus 1 over 7 exponent 3x. This is the particular integral, guys. Now that we have obtained the particular integral, we have equally obtained the complementary function. All we need to do is to sum up the two results. That's all. So we call equation 1 that equation 1 general solution becomes complementary function plus particular integral. And now we have the complementary function to be a exponent 3x plus a exponent minus x over 2 plus b exponent 4x, then plus or minus 1 over 7, which will have given us minus 1 over 7 exponent 3x. This is the answer to these very questions. So guys, you see that this thing is very, very simple. So simple. All you just need to understand is the principles. And I've echoed it over time that when you understand principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. Very, very important. So guys, don't forget to subscribe to this YouTube channel if you have not done so. And ensure that you turn on the post notification bell more exciting videos. So we are quickly going to look at question number 8, which will be a question to put more light to this aspect of second order differential equation. And we are asked to solve this square y over the x squared plus 14 dy over the x plus 49y is equal to 4 exponent 5x. Of course, the right hand side is not equal to 0. This has proven to us that this particular second order differential equation contains two answers. One is the complementary function, the other is the particular integral. Therefore, our final solution would have become the sum of complementary function and particular integral. Now guys, let's define that. We have y is equal to complementary function plus particular integral. We will call this equation 1. Alright, so let's repeat the same question that we were given, which is this square y over the x squared plus 14 dy over the x plus 49y is equal to 4 exponent 3 5x. Then we will label this as equation 2. Now from equation 1, we know that we are to obtain complementary function and particular integral all from this equation 2, which is the given equation. Now, for us to obtain the complementary function, we know that the right hand side of the given equation must be equated to the 0. Are we there? So, all we just need to do here is to say, to find the complementary function, let the right hand side of the equation be equal to 0. So we are going to replace 4 exponent 5x by 0. Then we have this to be this square y over the x squared plus 14 dy over the x plus 49y is equal to 0. So we label this equation. Now that we have successfully equated the given equation to 0, we can convert that equation to its equivalent auxiliary equation. And the equivalent auxiliary equation that corresponds to this equation would have been what? M squared plus 40m plus 49 is equal to 0. Now we can label this as equation 4 if we so desire. Now from equation 4, we understand that the equation we obtain is quadratic, and we can obtain the roots of the equation via any method of our choice as you are led. But let's use factorization method. Now we multiply this guy by this guy, and we are going to have plus 49ym squared, right? And we know that 49 is a perfect square. So 7 multiplied by 7 will give us 49, and 7 plus 7 will give us 14. We don't need to kill ourselves. Therefore, we have this to be what? M squared plus 7m plus another 7m and plus 49 is equal to 0. Now, at this point, all we simply need to do is to group the first two terms and equally group the last two terms. Now, between the first two terms, what is common? Only m. So you put down m, then open a bracket. M squared divided by m, we have m, plus 7m divided by m, we just have plus 7. That's all. Then we put down this positive sign. Now, between the last two terms, which is 7m and 49, m is not common. Then let's check if there is an integral that is common. Of course, 49 is divisible by 7. Then 7 is a factor of 49. Therefore, 7 is a common factor. When we divide 7m by 7, we have m, and when we divide 49 by 7, we equally have 7. This is equal to 0. And we said that what we have inside the first bracket must equal what we have in the second bracket for us to be correct. And that's exactly what we have. Now that we have successfully have that achieved, the next thing we are quickly going to do is to collate the multiplication factors, which are the factors that are outside the bracket. Are you there? So first we have m outside the bracket and plus 7. This will have given us one bracket. Then we can pick one of these equal brackets. Then we have m plus 7, and this is equal to 0. So we have m plus 7 is equal to 0, or m plus 7 equal to 0. When we collect like terms, we automatically have that 7m is equal to minus 7 or m is equal to minus 7. And from here, we have the two results that we have here, they are real. And now they are equally equal. They are the same. That means this is a part that is called real and equal roots. What do we do there? We just pick one m and say this is equal to minus 7 twice. And for this case, what is the general solution when you have real and equal roots? We understand that the general solution y is given as exponent mx open bracket a plus bx. This is it. So we only impute or substitute in the value of m. And we have that the complementary function, which is y, is exactly the same as minus 7 open bracket minus 7x open bracket a plus bx. This is what we have as the complementary function. You see, guys, this is very, very simple. And that's the reason why you need to subscribe to this YouTube channel and turn on the post notification bell for you to learn things much easier. Alright? Of course, there are so many things to learn if you keep following us. So many things to make it easy for you. Alright? Now subscribe and turn on the post notification bell. Share this video, like this video, make your necessary comment at the comment section. Okay? Now, the next thing we are quickly going to do is to obtain the particular integral. And for us to obtain the particular integral, all I need to do is to state to find particular integral. Recall that particular integral is equivalent to y and y is equivalent to a. Now we will now come here. What is the exponential function that we have here? You must ignore this constant. It is this constant now that we replace with c, the question. But we need the exponents. Alright, so we have exponent 5x, where 5 stands for k if we are here. Alright, stands for k. Now, if this is understood, the next thing we are quickly going to do is to differentiate y. We already know that y is equal to this guy. So when we differentiate y twice, we will be able to substitute into the given equation, where we will be able to obtain the value of c, which is the arbitrary constant. Therefore, we differentiate d square y over the exponent is equivalent to, when we differentiate like I explained before, all you just need to do is to differentiate the power of the exponential function, which is 5x. When you differentiate 5x, guys, you have 5. And that 5 will now multiply the coefficient of the exponential function. So we will have this as 5c exponential 5x. Then divide, then differentiate the second time, which is the second derivative. When we differentiate the second time, we are equally going to differentiate the power of the exponent, which is 5x. When we differentiate 5x, we will equally have 5. And when we multiply 5 by the existing coefficient, this will have given us 25 c exponential 5. Now that we have obtained y, the y over the s, and this square y over the s squared, all we need to do is to substitute those values into the given equation that we type equation 2. And when we have that done, we will be able to obtain the value of c. So now we have that. In place of this guy now, we will replace it with 25 c exponent 5x. Then in place of this other guy, we have 14 multiplied by 5 c exponent 5x. Then plus 49 multiplied by what? C exponent 5x, which is y, all equal to 4 exponent 5x. Now, if this is understood, the next thing we quickly do is to clear off the brackets, alright? So this will have given us 25 c exponent 5x. Now, 14 multiplied by 5 is 70. There we put down 70 c exponent 5x, then plus 49 c exponent 5x, all equal to 4 exponent 5x. Now, at this point, all we simply need to do, we find out that c exponent 5x is common across each term that we have at the left-hand side of this equation. all we need to do is to factorize. Okay? Now we bring out C exponent 5x, which we have 25 plus 70 plus 49, all equal to 4 exponent 5x. Now 4 exponent 5x, we cancel out exponential 5x, or simply divide all through by exponential 5x. We have that eliminated. Then finally, we are going to add this together. Now, 25 plus 70 would have given us 95, and 95 plus 49 would have given us 144. Then we have 144 multiplied by C is equivalent to what we are left with here is 4. Therefore, when we make C the sort of formula, we have 4 over 144. And now, 4 is a factor of 144. 144 divided by 4 would have given us 36. Therefore, this would have given us 1 over 36. 4 into itself is 1, and 4 into 144 is 36. We do not need decimals here, so we leave our answer in fractional form. If this is understood, then the next thing we quickly do is to recall that the particular integral is equal to y, and y is equal to c exponent 5x. And we have that particular integral is equal to, what is the value of c? 1 over 36 exponent 5x. This is the particular integral. Now guys, we have obtained the complementary function. We have equally obtained the particular integral. That is to say, to get our general solution, we just need to sum up the two results. Then we are done. We have that the general solution to this order of differential equation is complementary function plus particular integral. This is what we define as equation 1 when we started solving this question. Now, what is our complementary functions? Complementary function here is exponent negative 7x open bracket a plus bx plus 1 over 36 exponent 5x. This is the answer to this very question. Guys, you see that solving problems under second order differential equation when f of s is not equal to 0 or f of s is equal to any value is very simple. Very simple. But all you need to do is to ensure that you understand the principles, you understand the steps, and you understand the processes involved. If this is understood, therefore you don't have issues. Now guys, don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell, more exciting videos when being uploaded. Guys, don't forget to share this video, like this video, and make your necessary comment. Love you guys. Thank you for watching. You can check the description below where you will find the link to the next video. See you guys in the next class.